Okay, we're going to solve some equations here ultimately with the inverse. So what does an inverse do? What does it look like? Well, before we can look at inverses, we have to look at what an identity matrix is. And an identity matrix looks like one of these forms up here. Could be bigger. An identity matrix is always going to be a square matrix. It's going to have 1 down the diagonal, and then all the other values will be 0. The nice thing about the identity matrix is if you multiply it by any matrix, it will result in that particular matrix that you have. So kind of like if you think about the multiplicative identity, 5 times 1 is 5. The multiplicative identity is 1 because when you multiply by it, you get that other value as the answer. Same thing with an identity matrix. Okay, so another thing that you may have learned in elementary school is that if you multiply a number by its multiplicative inverse, that means you multiply it by something, and the result is 1. So 5 and 1/5 are multiplicative inverses of each other because the answer is the identity. Okay, so similarly to that is this idea of matrix. You can multiply by an identity matrix and get the original matrix back. Similarly, if you have two matrices and they are inverses of each other, then when you multiply them together, you will get the identity matrix. So that's kind of what that is in a nutshell. Let's put it to use here. First things first, we're going to show that when we multiply it by the identity matrix, which is the I, and it doesn't matter which comes first. Recall when we talked about matrix multiplication, we said that matrix multiplication is not commutative, and it's not. However, when it comes to the identity matrix, it is commutative. So that's the only case you can put the identity matrix on either side, and you will get that matrix back. So that's what they're saying here. So let's do this math. If I have the matrix 3, 4, -2, 5, and I multiply it by the inverse, okay? Remember multiplication, rows, columns. So it's 3 times 1 plus 4 times 0, right? Row times column, and we keep doing that. First row times second column will be 3 times 0, 4 times 1. Next, bottom row, first column, -2 plus 5 times 0, 0. Next, second row, second column, 0 plus 5. And in the end, you see here we have 3, 4, -2, 5, which was the original matrix we started with. So putting the identity behind it and multiplying it produces the original matrix. Now we're going to do it in reverse order here. So we're going to start with probably something bigger than that. 1, 0, 0, 1, and we're going to multiply it by 3, 4, -2, 5. Okay, same deal, rows, that was supposed to highlight, rows times columns. Okay. One more back. Maybe. All right, row times column. Come on, get done. All right, 3 times 1, row times -2. Next row, column, 4 plus 0. Bottom row, first column, 0 minus 2. Next, bottom row, second column, 0 plus 5. All right, and in the end, 3, 4, -2, 5, the identity matrix. So that does what, excuse me, that's not the identity matrix, that's the original matrix. So, okay, next, we're going to go here and we're going to show that these two are inverses of each other. Now remember, inverses of each other, a matrix times its inverse will result in the identity matrix, and it goes both ways. Okay, so first we'll do A times B. Row, column, -9 plus 10. Next row, column, 5 plus 5. Bottom row, first column, 18 minus 18. Bottom row, second column, 10 minus 9. AB is equal to 1, 0, 0, 1. Yay! Now, that's not enough. We have to do it the other way as well, which is B times A. Now, I do not like having the matrix backwards. So here's B. I'm going to rewrite A here. There we go. Now it's B times A, which means this is row times column. Okay. -9 plus 10. -45 plus 45. Bottom row, first column, 2 minus 2. Bottom row, second column, 10 minus 9. And in the end, this product is 1, 0, 0, 1. We got the identity matrix each time, so we have verified that they are inverses of each other. Okay? All right. This one says use matrix multiplication to find the inverse matrix. I can actually find the inverse matrix a couple different ways. There's 3 different ways, actually. I'm going to show you 2. All right, first one is we're going to use matrix multiplication to do that. Consider this. If this is my matrix, then there should be another matrix such that when I multiply them together, I get the identity matrix, right? If there's an inverse, that will happen. So I'm going to, and it's going to be with variables, but I'm going to multiply. 1a minus 2c. Okay, I'm going to row this column. Okay, I know I got to keep in that. So second column is going to be b minus 2b. Bottom row, first column, a minus 3c. Bottom column, 2b minus 3. Now, that's multiplying these two together, and it should equal 1, 0, 0, 1, which means a to c should be a 1, and 2a minus 3c should be a 0. I can solve, here I have 2 equations, 2 variables, so I can multiply the top equation by a -2. We'll get -2a plus 4c equals a -2. Second equation, 2a minus 3c equals 0. And when I add them together, we get 1c equals -2. I like that. And if c is a -2, think about, you can back substitute, right? I'm going to back substitute it into this one right here. A, which means not done yet because I don't know B or D. So these last two are telling me that B minus 2D is 0 and 2B minus 3D is 1. Okay? I'm going to multiply the top equation by a negative 2, negative 2B plus 4D equals 0. Second equation I'm not going to change. And we add 1D is equal to 1. I'm going to back substitute. I think I'll use this one. B minus 2 equals 0. Oh, B is 2. All right, I have all four now. So I can say that the inverse A, B, C, D is A, B, C, D. There's my inverse. Okay? All right. So that's one way to do it. It's more algebraic. Here's the next way we can do it. If a matrix exists. Okay? Sneaky, they put that on there. So let's try it. Here's how this is like kind of option 2. 3, 6, 1, 2. Okay? So put that matrix down. But behind it, I'm going to write the inverse. And I'm going to extend it into a, basically it's going to be, looks like a 2 by 4 matrix. 1, 0, 0, 1. Okay? And now I'm going to do our row operations that we learned earlier in this chapter, right? And I'm going to try to get a 1 here, okay? Basically, I'm going to manipulate this so that the identity is the first 2 by 2 that we see there, and then the inverse will be the second 2 by 2, okay? So I'm going to flip-flop row 2 and row 1. 1, 2, 0, 1, 3, 6, 1, 0. Okay, that's, remember there are steps for finding. Basically, I'm doing like row echelon form to get the identity matrix. Now I need a 0 there where I have the 3. So my new row 2 is going to be row 2 minus 3 row 1. And I like to work vertical. So I'm not changing the first row, but the second row will be 3 minus 3, 6 minus 6, 1 minus 0, and 0 minus 3. Now here's the issue. I don't have a way of getting a 1 there. Okay, so that means no inverse exists. So point is, not every matrix has an inverse. Okay. All right, let's do that same method, but let's do it with this one. 3 by 3, we're looking to find the inverse. So we would do a 2, 3, 1, 3, 3, 1, 2, 4, 1, and then behind here, we put the identity matrix. So this is a 3 by 6. Okay. First goal, we need here. I'm going to do row 2 minus row 1. 3 minus 2, 3 minus 3, 1 minus 1, row minus. I'm here now, 1 minus 0. It's not true. It's a small delay here. Oh my goodness. The heck? 3 minus 2, 3 minus 3, 1 minus 1, 0 minus 1, 1 minus 0, 0 minus 0. And then the second doesn't change, and the third doesn't change. Okay? All right, now I need a 0 here. So we're going to do row 2 is equal to row 2 minus 3 row 1. Okay. 1, 0, 0, 0, 0. All right. 3 minus 3, 3 minus 0, 1 minus 0. The same thing again. 1 0 plus 3, 1 minus 0, 0 minus 0. Okay. I didn't change the third. Okay. All right. Now 0. So 3 is row 3 minus 2 row 1, 0, 0, negative 1, 0. I'm not changing this row, so leave it like that. Third row is one change. So it's going to be a 2 minus 2 0 minus 0 a 0 plus a 0 minus 0 minus 0. We're going to here and there. Row 2, 3 minus row 2. Minus 4, 3, 1 minus 1, 2 minus 3, 0 minus 1, 1 minus 0. Third row I didn't change yet. And now I need a 0 here. So we're going to say row 3 minus 4 row 2. All right, let's get some more space here to work in. Not changing row 1. Not changing row 2. Am changing row 3. It'll be a 0, 0. This next one will be a 4 minus 4. Will be a 1, 0. Now will be a plus 4. A 0 plus 4. Last one will be a 1 minus 0. Now, if you look here, I have the identity matrix. So that means right here, I have the inverse matrix. So A inverse is negative 1, 0, 0, negative 1, negative 1, 0, 6, 4, 1. Okay, I'm going to stop this video. We're not done with this section, though. We're going to also talk about how to use inverses to solve systems of equations. So that's next.